Subspaces are special sets in Rn. So we speak of a WB in Rn being a subspace of Rn. It's also called a linear subspace of Rn if it has the following properties. There are three characteristics of a subspace. Well, first of all, we should have that the zero vector belongs to W. The second property, if we take two vectors in W, then the sum of these vectors should also belong to W. So this means actually that W is closed under addition. If we take two elements, add them, then we are not leaving the set W. The third characteristic and final characteristic, take any scalar and a vector in W, then k times x also belongs to W. So similar to what has been said before, so this can be considered as closedness under scalar multiplication. So if we have a vector x, then k times x also belongs to W. So we stay in the set. It's closed in this sense. So consider an example. You may question whether the following plane is a linear subspace of Rn. So x plus 2y plus z equals 3. Well, the answer is no. It's not a subspace because clearly the zero vector does not belong to V. V is not a plane through the origin. The following, instead of 3, now we take 0. Well, this V is a linear subspace. First of all, the zero vector belongs to V. It's easily checked as follows. Secondly, take two vectors x and y in V. Then x1 plus 2x2 plus x3 equals 0. And x1 plus 2x2 plus x3 or y3 also equals 0. So if we add x1 plus y1 plus 2 times x2 plus y2 plus x3 plus y3, then again we obtain 0. Since we can reformulate this sum, split the sum in two parts of which we know that they are 0. So this is 0 plus 0 equaling 0, meaning actually that x plus y is also a vector satisfying the restrictions of this plane. Now take x in V and the scalar k. Then k times x1 plus 2 times k times x2 plus k times x3 equals k times, we take it out, k times x1 plus 2x2 plus x3, which is 0, k times 0 equaling 0. So k times x also satisfies the equation for the plane. So k times x belongs to V. So this plane has the three properties, so V is in this case a linear subspace.